This is Ms. Haslauer's first video on scatter plots and volume review. Remember that you have a test tomorrow. It's very important to study. There's key components to this video, though, that you need to remember that will help you succeed tomorrow on your test. By the end of the video, you need to know 1. Your key vocabulary for scatter plots, 2. How to construct a scatter plot, 3. How to draw a line of best fit, or also known as a trend line, and 4. Your 5 important equations. You've got your 3 volume ones and the 2 circle equations. You need to know all 5. I am not giving you any of them. They are up to you to memorize, so make sure you know them. All right, we're going to start off by finishing up our class notes. So if you have that with you, please take it out and follow along with the following examples. Example number 4, according to a certain linear prediction equation, a person 25 years old needs 2,400 calories of food intake per day. A person 30 years old needs 2,300 calories per day. Let X stand for the age in years and Y stand for calories. Find the prediction equation and find the approximate caloric needs for a person who is 35 years old. So if you have to find the equation of a line, you need 2 very important things. You need slope and you need y-intercept. This word problem doesn't give you exact coordinates, but it gives you the information to create one. 25 years old is associated with the 2,400 calories, so that's your first coordinate. And then your second will be 30 years old, matching with the 2,300. Again, the 2 things you need are slope and y-intercept. Your slope equation, you have to know it. It won't be provided to you, is y2 minus y1 over x2 minus x1. Now, all you're going to do is substitute in. You've got your 2,300 minus 2,400. Those are your y values. Minus 30 minus 25. Remember, the negatives win, so you get negative 100 over 5. Same sign positive, different sign negative gives you negative 20. Once you find your slope, now you need your y-intercept. Standard form of a linear equation is y equals mx plus b. So we start to sub in and we've got y equals negative 20x plus b. The problem is, if we need to solve for b, x and y, both those variables have to turn into numbers. Now, just think about it logically. If you have to have b as your only variable, x and y makes up any coordinate. All right, we've used 2 coordinates already to find your slope. Now you pick one of them to find your y-intercept. It doesn't matter which one you plug in. Either one is fine. I'm going to use 30, 2,300. So I'm going to plug in 2,300 for y. Remember that x comes before y. Make sure you sub in for the correct variable. And you're going to plug in 30 for x, and now it's just a very simple solving problem. You've got 2,300 equals negative 600 plus b. The way you move a negative 600 to the other side is by adding it, your inverse operations. And you get 2,900 equals b. Now you put it together to make your standard linear equation. You got m equals negative 20, so the slope is negative going down, and your y-intercept is 2,900. By putting those 2 values together, you get the linear equation y equals negative 20x plus 2,900. There's your answer to part A. They wanted the equation of your approximation. All right, so there it is right there. But this is a 2-part question. After you find the equation, it says find the approximate caloric needs of a person who is 34 years old. Now, if you look over here at your coordinate, 30 represented how old the person was. The 2,300 represented the amount of calories they need. So instead of looking at 30, now we're looking at 34. So 34 is going to be subbed in for your x. A variable represents an unknown number. It's not unknown to me right now. I know that's 35. So you take your negative 20. You're going to sub in 34. And now you're just going to solve. So you get y equals negative 20 times 34, same sign positive, different sign negative. You get negative 680 plus your 2,900. And you get y equals 2,220. Now, this is the whole reason why we find this equation. All right, you're going to use your line of best fit or your trend line. All right, they mean the same thing. To predict, to use what data you have and then make an assumption. That's why it's so important. With scatter plots especially, you can't use the data as is to predict anything. You have to have your trend line to support your results. So again, please make sure that you are reading a word problem completely. This was 2 parts. All right, don't do all the hard work to find the trend line equation and then skip the substitution step. All right, make sure you're reading the word problem completely. This is the other problem that we didn't get a chance to finish in class. It's a great question that makes you think a little bit, all right, but it's not hard. All right, which equation most closely represents the line of best fit for the scatter plot below? So instead of being asked to draw your line of best fit, it's giving you 4 options, all right? This is a great question because you got to think. And guys, don't be afraid to grab a pencil and a ruler and draw the equations that they're presenting to you. It's so much easier if you can actually look at it. So for example, question number 1, equation number 1 is y equals x. That's the same thing as y equals x plus 0. The 2 things you need to graph a line are m and b. Your slope is 1 and your y-intercept is 0. Okay, well, what does slope tell us to do? Also known as rise over run. We're going to go up 1 and right 1. Where are we going to start? At 0. So we're going to start at 0, and you're going to go up 1, over 1, up 1, over 1, up 1, over 1, and you're going to continue your pattern. Now, if I were to connect all of these dots, all right, you would get a line of best fit. I know that's not a nice line. I would have to use my ruler. All right, is that a line of best fit? Absolutely not. You've got all these dots on the top and only a couple on the bottom. Please remember, line of best fit should go through the center of your data. It should have as many data points above the line as it does below. This one is not the answer. All right, that is not the most appropriate line of best fit. Well, in any multiple choice question, 1 of the answers is right and 3 are wrong. So that one's definitely a wrong one. Okay, let's go to number 2. Y equals 2/3 x plus 1. Slope is 2/3. Rise over run, and your y-intercept is 1. So we're going to start at 1. Up 2, 1, 2, over 3, 1, 2, 3. Up 2, 1, 2, 3. Up 2, 1, 2, 3. Up 2, 1, 2, 3. Again, here's my line of best fit supposedly. It completely deviates from the pattern of the data. It does not go through the center. Don't pick that one. That one does not work. There's no way you're going to have as many data points above as you do below. Number 3, y equals 3/2 x plus 4. Okay, we're going to travel with our change in y over our change in x of 3/2. Our b is 4. So we're going to start over here at 4. We're going to go up 3. 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2. No. This is the opposite of the other ones. This one will give you a trend line that's above the data points. Again, you want as many above as you do below. That one is not going to work. That one does not go through the center. It's too high above. Now, do not just assume that the 4th equation is going to work. Maybe we graphed one of the other ones incorrectly. All right? Do not assume anything. Test it out. Slope and y-intercept. Slope is 3/2, and although we've just did a slope of 3/2, number 3 tells us to start at 4. All right, this equation tells us to start at 1. So we put a dot at 1, and we go up 3, 1, 2, 3 over 2. Up 3, 1, 2, 3 over 2. Up 3, 1, 2, 3 over 2. And up 3. Oh, we can't fit. But sure enough, if you put a ruler up to this and connected your dots, you would end up with a line of best fit that goes through the center of your data points and has approximately the same number of data points above as it does below. This is a perfect line of best fit. So go through your options, graph them, and see which one is best. This is just another way of asking you the same question. How do you construct a line of best fit? It needs to go through the center. All right, so it's definitely number 4. All right, and I only know that by graphing. There's no trick to it. Graph it using your M and your B. Okay, so now that we're done with the notes from today, now I'm just going to do a quick review with you guys. Make sure you've got everything you need to be successful tomorrow on your test. But again, look over your notes as well, guys. I can't cover everything in the video. All right, so quick vocabulary for your scatter plots. You've got 3 types of correlations you're expected to know. You've got your positive, all right, just like we know with our lines, with our linear equations, if the data set goes up, forms a pattern going up, that's your positive. If they form a pattern going down, that's negative. Remember that we always read graphs from left to right. So they start high, they end up low, that's your negative. And then if they're just kind of scattered all around, all right, that's your no correlation. A scatter plot is drawn to display bivariate data. Make sure you know that vocabulary word. All right, bivariate data is when you're comparing 2 things that are linked. 2 things that are linked. Study time to grade on a test would be bivariate data. They are linked. Shoe size and average grade on a test would not be linked. They have no correlation with each other. All right, so again, you've got more notes on that, and you have more information on that vocabulary word in your notebook. But again, bivariate data is 2 data sets, 2 components compared if they're linked to each other. Now, try it on your own. All right. Each one of these is an example of the vocab word we just went over. This is an example of a negative correlation going down. This scatter plot is an example of a positive correlation because they go up. Again, a positive linear because the dots do resemble a line. And then this one here is definitely an example of no correlation, all right? No correlation or no association. You can't draw a scatter, you can draw a scatter plot that has no correlation, guys, but you can't draw a line of best fit because the dots are just all over the place. Don't assume anything. If they don't make a pattern, you can't make a trend line. There's no trend to the dots. And all it means is that there was no correlation between the 2. They're not related. Which graph shows the most accurate line of best fit? Again, very important to understand this line of best fit. Here is 4 examples of the exact same scatter plot. It's all positive linear associations, but this line is too low. You got a bunch of data points above, not going to work. This one is the opposite. Your line of best fit follows the trend, but it's too high. All the data points end up below. That one doesn't work. This line of best fit goes through the center, and you've got 4 on top and 4 underneath, but it doesn't follow the trend. All right, all this does is cut the data points in half. It does not follow the trend. Your best option is absolutely Z. It goes through the center, follows the data sets. It's close, very close to all the points, and you've got 1, 2, 3, 4 dots below, and 1, 2, 3, 4 dots below or above. Got to have the same number below as you do above. That's what you're shooting for. It doesn't always work out that way, but you really do try your best to make it look like that. That's a perfect example of a line of best fit. You are going to have to draw your own, and you're going to have to come up with the equation for ones that I've drawn. What do you have to remember about drawing the line of best fit? All right, we've talked about it. 1, it should be drawn through the center of your data with as many points above as below. Very, very important. Here's your positive linear association. You would take your ruler and you would do the best you can to draw a trend line right in the center. It does not have to pass through any of the points. It can pass through the data set points, but it doesn't have to. That's very important. And 3, a line of best fit cannot be drawn if there's no association in a scatter plot. This has no correlation at all. All right, the trend line demonstrates just that, a trend, a connection between the 2 bivariate data. This no correlation does not. All right, no trend lines for no correlation. Do you remember what the dot is called inside the box? That's an outlier. Very important to know what an outlier is. It does not fit the trend. See how this is positive linear? So you do not pay attention to the outlier other than to mention it. It's not considered when you're drawing a trend line. It's not considered when you're deciding if it's positive or negative. You just mention it as the fact that you know it's there. All right, it's important. It's still part of your data set, but it doesn't play as large of a role because it's called an outlier. It's outside of the data set. The other really important part of the test tomorrow is knowing your volume equations. There are 3 new volume equations that you have to know, but some of us are still struggling with that. This is a cylinder. All right, you guys, the shape on the bottom of a cylinder is a circle. All right, pi is very important whenever you're finding area of a circle. The area formula for a circle is pi r squared. But it's not just one circle. It's a bunch of circles stacked on top of each other. So you take the pi r squared and then you multiply by the height. This is a cone. Please remember we talked about the fact that it will take 3 cones to fill one cylinder. Again, 3 cones to fill one cylinder. That's where the volume equation 1/3 pi r squared height came from. All right, it's the same equation just about as your cylinder, only it has the 1/3 in front of it because it takes 3 cones to fill up one cylinder. And the last volume equation you have to know is your sphere. And this one's a little bit more challenging. You have to memorize it. It's 4/3 pi r cubed. All right, there's no height to speak of, guys. There's no height like there is in a cylinder and a cone because it's a sphere. It's just it's a baseball or a tennis ball. All right, and it's 4/3 pi r cubed. You have to know it. It's the only one that's cubed. The other 2 are squared. It's a must. I'm not giving you the equations. You have to know them. Please, please, please memorize those. The other 2 you have to know are your circle formulas, but again, those are really easy. Your circumference equation, again, that's just just perimeter of a circle, all right, but there's no exact edges. It's round, so you have to know your special equation. Circumference is pi d, or you can tell me circumference is 2 pi r, all right, where d is diameter and r is radius. And then your area of a circle, just as important, is your pi r squared. We've got this little jingle down here to help you remember. Cherry pies are delicious, or cherry pie's delicious. All right, C equals pi d. There's your equation for circumference. And then apple pies are 2. Right? Just a way to help you remember your equations. You've got 5 of them you have to know. If you know your equations, the word problems end up very simple. If you don't know your equations, there's nothing you can do for it. So I put one example of a volume question, something that you'll see tomorrow. But again, you've got a lot of resources and a lot of examples in your notebook to check out. Find the volume of a cone with a height of 5 inches and a radius of 3. Find your answer in terms of pi and then round to the nearest tenth. So again, guys, very simple if you know your formulas. I'm not providing it for you. It's very important that you notice it's a cone. A cone volume formula is V equals 1/3 pi r squared. Height of 5. Can't forget that we got to multiply it by the height. So again, there's your formula, 1/3, because it's 1/3 of a cylinder. Pi r squared, that's your area of a circle formula because that's the base of a cone, times how high it is. You leave the 1/3. We're going to leave the pi, guys, because it says in terms of pi. In terms of pi means leave the pi symbol there. We're going to plug in r. We got a radius of 3 and a height of 5. Now it's up to you. If you have access to a calculator, you could type this in using your commutative property by putting pi on the outside. We could do a little bit of work. 3 squared is 9. All right, and again, using our commutative property to kind of shuffle the numbers around a little bit. And then you will have access to a calculator. I'm going to type in n over d, 1/3 times 9 times 5. Or we could use our cross simplifying. This would turn into a 1. 3 into 9 would be 3. And you do get 15 pi inches cubed. Very important to remember that volume is always cubed. All right, there's your answer to part A. Leave your answer in terms of pi. In terms of pi means do not plug pi into the calculator. Pi just stays. But then your answer to B is round to the nearest tenth. You're going to take your 15 pi Remember that pi is a number. We're going to replace it as 3.14. Type it into the calculator. And you get 47.1 inches cubed. Very simple to find volume, but if you don't know your equations, you're not going to be able to do any of the work. Yes, you will have a calculator, but again, the calculator does not have anything to do with the formulas. You have to know all 5. They will come in handy, and you have to know them, guys. They're not going to be on the test. Again, in terms of pi, just means literally that pi is still there. Very important to understand the meaning behind that. And then when they ask you to round, whether it be the tenths or the hundreds or the thousandths place, that means replacing the symbol pi with the number. All right, your test is tomorrow. Look over your notes for more example problems on both volume and scatter plots. This is only 20 minutes. It did not cover everything. Make sure you look through your example problems. All right, for 2 points on your test tomorrow, write FSCS for Frankfort Schuyler Central School on the top right corner of your paper, guys, just so I know for a fact that you did watch this video. Don't tell anybody about the key phrase, or else you're going to lose your 2 points. All right, I got to see who watched the video and who didn't. And I can't wait to hear what you guys think, and I'm sure you're going to have lots of good advice for me. All right, so make sure you study, guys, and you'll be fine.